Hi there, welcome back to my channel. If this is your first time, thanks for stopping by and I hope to see you in my next videos. In today's video, I will be teaching you. In the meantime, let me just clean the screen so it's not super distracting. You could do this by just going into my dedicated folder for this sort of tutorial. And now that I'm there, I will generate a new script, and you could just use edit and give it a name. Maybe let's just call this computer vision intro. So I'm just going to introduce computer vision to you in this particular video. Let's do .py, hit enter, and now we have created a new script. We'll make this a little bigger. I'm just holding the command. I'm using Mac, so I'm holding the command, and I'm doing a plus just to make this a little bigger. And I'm using Python, so to say. It's a code interpreter. Think of it as a software that allows you to write code and execute code. In this case, Python. Alright, with that said, in this particular video I just want to do a brief intro into computer vision, and after this particular video I'll be doing a series of videos that will be focusing on computer vision related projects. And so I'll pick a good project and that will allow my viewers to learn how to execute these computer vision projects. So I'll pick it and then we'll code it from scratch to the end, and again I'll make the code available on my GitHub. In today's, I'm not set up to share all those stuff, but I'll link it in the description of the video at the end of the video. And so to start, I will just go through the basic of computer vision in Python. I will explain to you what pixels are, what makes image, why image look the way they are, and how computers interpret or understand these images. I will also touch a little on edge detection and feature detection in these images, and blurring, and just get to understand intensity, how to load these images and how to visualize them in Python. So I hope to make it a little short. We're already having 2 minutes running down, so let's go straight into it. So in this particular folder, we are just created this script now. I have a folder called image, and in that image I have one image of myself that is called Ben, which is the short form of my name. It's a PNG and it's a colored image. So we'll be reading this image. I have some code somewhere, so I'll just copy paste and edit just to save our time so we don't stay forever. So the first section is just, let me just add a comment, and to add a comment you just do a pound sound and then a sign, and then you could just put in, so the code interpreter doesn't get to execute those lines of code. They're just for comment. So let's call this setup and load image. So we're basically setting up and loading image in this section. And for the setup we just need these two libraries. I mean, at some point we are importing NumPy, which are for operating on numeric arrays in Python. The OpenCV, most of the computer vision tools or methods that we need to operate on those images are contained in that package. So it's like an OpenCV, it's like an open computer vision. So it's a package for operating on or executing this computer vision project if you don't want to code them from scratch. There are a bunch of good methods and functions that are available within this package, so you could install it. It's a library in Python. And so I'll run this, and to run the line, just this line of code, we just have to do this I and 1. Before that, let's just make sure our setup is proper, because if I, for example, want to make an image and I'm not properly set up, it wouldn't display. So to do that, you have to go to this spanner, the settings, click on this, and it should open up this tab, or rather this interface, and you could go to this console. We want to click on this IPython console, and we want to go to the graphics, and we want to make sure this is on automatic. If it's not on automatic, if it's on inline, for example, your plugin will be within the spider plugin or output command window. We want it to be on automatic so that it will utilize my resources, my other visualization resources available on my Mac to make these images. It becomes easier. It's more like you have figures that are interactive, so you have more control basically. And so let's import the two libraries that we'll be needing for now, which is OpenCV and Matplotlib. Matplotlib is for basically for plotting in Python. So we have loaded those. So here we don't have any error, so that was successful. And let's load the image. So first I'll set the path to where my image is. Maybe I should make this a little bigger. Path to where my image. So I'll just create a string, and there's a folder where I am that is called image, and in that image there is a band.jpg. And so this points to where my image is, and now I could read the image by just using OpenCV.imRead. So this is where we read the image. So basically I'm reading the image here, reading the image. So to read the image, there's a function called imRead, which is image read. So just do OpenCV.imRead and then tell it the path where this image is, and this is the path I provided up here earlier. And if I run this line of code, I should be able to read the image. So I've read the image, and here in my variable, maybe if I delete everything here just to clear that, and I repeat this again, what I just did, I just cleared the memory, so it's supposed to have it before it to be out. I'll have a variable called image, but that's not important. We could just type image here, and if we hit enter, we should see that yeah, we have data. So basically we have the information that we've read, it's already in memory. But if you look closely on this here too, you find it. So that's the image, just to show you. That's how it looks like, the image that we've read. It has three channels. The red, in this case it's BGR, so it's a blue, the green, and the red. So these are the combination that it's like giving some, it's through this combination that we're having the colored image that we're seeing. But it's basically a combination of three channels. I'll explain that more just in a bit. I think if I click on this, yeah, the visualization is the same. I was hoping I will have like something better, but yeah, never mind. And so now we have this information read into this variable called image. Let's try to visualize it. And since it's a colored image and we're planning to use Matplotlib to read it, we need to convert it from the BGR, which is the way that OpenCV will read the image. It will read it as blue, green, red, so that's how it organizes it. But if you plot it this way, it wouldn't look great. It would give it, like, because of the mismatch of the arrangement of those channels, it wouldn't look like the way you have it on your phone or wherever device that you preview your images. The proper way, or the standard way, is having it in red, green, blue, which is the way the Matplotlib, the package that we're trying to use to visualize this image, we expect the image to come out. And so we're going to convert it from BGR and reorganize the channel so that we'll have RBG. This way we could use Matplotlib to visualize this image. I'll plot both of them just in a while just to show you the difference. But let's add a figure. So to plot, I'm just calling the figure, and on this figure using PLT, which is short form for Matplotlib, as we earlier said here. And to show the image, we're using imshow. So just do imshow and then provide this image that we've converted to RGB. And you don't need to give it a title, but if you want to give it a title, you have to appear to the title, and then you give it a string that should appear at the top. And you could silence the access, or you could leave it. If you don't silence it, you have numbers. So if I run that now, it should plot, and it's going to show up right here. So that's the image that I have. It's a colored image of me standing close to the board, and suppose I silence that, these numbers would have gone away, so it will look more like what you see on your phone. You don't have those numbers. So let me just close this and silence that and run it again. So if I run it now, it will plot it without those numbers. Again, if you remove the title, the original image will go away. But also I want to plot the other image that I had originally, just to give an idea of suppose we didn't convert this to RPG, how Matplotlib will visualize it. And so this will be, let's just delete the title, it's a bit, or call it the raw. Let's call this the raw image, which is the first one that we read, and we'll call it image. So we'll just copy that image and we'll replace this with the image. And if we run this now, you see weird colors. Yeah, because the blue comes before the green and the red, so the organization sort of like throws it up. Or if you plot it within OpenCV, it will look really good because that's how it's expecting it. So just something to have in mind when you're visualizing your images. If you run it, that's how to fix it. You have to convert it, and to convert it, you just have to do CVT, just convert to color. That's just the full meaning of that function. Okay. So with that said, we are able to load, convert, and read these images at this point, which is a good achievement so far. So I'm going to leave this by the side, and then we'll go to the next one. Next one is, well, what if the image is not colored? What if it's gray? How do you read it? Or can you even convert your colored image into gray image? So with the gray, basically you have a single channel and it's like black and white, but you have more details because you're like let me just plot it and then I'll explain. So now we want to show the pixels in terms of like using the gray, and to do that you could use the same function. Instead of like using this convert BGR to RGB, you could convert the BGR to gray instead. And so if I run this code again, I like adding this figure so that it doesn't override the previous one, so in case I want to go back to those. So let's just run this line of code. Now instead of like showing this image as color that we had it here before, now we're showing it as a gray, so it's basically black and white. It's a black and white image, and to convert it you just need to do that. Or right from when you're reading this image, another hack, it's this imRead. So if I create a new variable here called gray, another way would be to just provide a 0 flag called 0. So just tell it that read it as a grayscale. So if I run this now, which runs successfully, if I plot this image, which one should we use? Let's just change this our gray here to that gray image, and this should plot another gray image for us. So that's another way of like plotting the gray image. So yeah, just something to have in mind moving forward. Okay, and so now that you have known how to load these images and visualize them in Python, another useful thing that you may want to know is how does computer actually understand this image. I mean, for us, we could see this, we have eyes, we look around our environment and we're able to see stuff, structures and features, objects, and understand that, oh, this is a bottle, actually this is a car, and stuff like that. But computers, they don't have these eyes. How do they understand this image? I mean, and the answer to that is through pixels. So images are comprised of pixels. So if I bring up one of those images by just doing the plt.show, here, if as I'm running this through, if you look at the corner or the right, you see the numbers changing, and those correspond to pixel values. Those are intensity values that correspond to the pixel. And think of it as this image having grids. So there are grids, tiny grids, and each of those tiny boxes, and those number of boxes, you could know them by knowing the shape of your image. So if you do a shape of this image, it will give you some dimension in X and dimension in Y, which let's just get that really quick. Or in fact, it's even here. So if I come to this image, it gives me the type. The type is unsigned integer 8, which is just like the number of details within each of like, it's think of it as like a gradient of like intensity values or color values within a single channel. So numbers could range up to 255 within 1 pixel. So it could be a 0, it could be 100, or it could go as high as 255. The more you have those numbers within that particular position, your image, the better your image looks. So think of it like, for example, you have just black and white, pure black and white, it's a number either 1 or 0, then or either 1 or 255, then you just have pure black and white. So there's nothing like gray, there's no shading in between. But the more details or the more range you have here, the more details or the more interpretable or easy to comprehend the images. And so these are the dimensions of this particular image. It has 6,000 in the vertical, which is the Y, and then it has 4,000 in the horizontal, and it has 3 channels. So it has the blue, the green, and the red. And this is how the values look like. In this case, it's an unsigned integer 8. So again, as I said, it goes from 0 to 255. And because of that, you have some values. So if I click on that, it will open these values, and each of these values is like what you're saying in that. So there's like some future here. It's not the best way of visualizing it, but it has all the numbers, basically, the 3 channels. And I think it's flattened, that's why you're having that. Oh, it's just showing one axis. So if I switch to the next axis, so that was the vertical, now it's the horizontal, and you could switch to the third one, which is the full one now. So this is the image. The future that you're seeing it, you could see those here. So if I scroll through, you see how stuff are changing. These are like the numbers that make up the image. So this is how the computer see the image actually. So now I'm showing you the full range of the image. It's 6,000 by 4,000. If you look through everything here, you should be able to see where we're standing. This is like the board with different numbers. Densities are changing, and where the human being is standing, you should be able to also like see it's like some whatever. So that's that. It basically sees it's at numbers, and based on these numbers, if you assign those intensities and visualize it, you're able to see those images. So that's basically how it sees the image. Another operation that we could do on these images is to blur them. So let's try to blur an image. Again, I have a piece of code here. I'll just copy it and paste it right here. And let me, before I run this one that I want to paste now, let me just let me make this a little bigger and scroll up. You could also like evaluate positions in your image to know the intensity. So compared to like the way I just opened the entire image to show you, for example, if you want to know what is in the image at position 100 in the vertical and position 100 in the horizontal, you just slice the data. So since it's two-dimensional data, provide this, slice at this index and slice at this index. So this will print the pixel value, which is the intensity at that particular position. So let's just run that. If we run that, it tells us that the value here was 199. So that's like kind of like the brightness level. It's bright. It's not a dark pixel. Supposed to a very low value, say to you, that would have been a dark value, but it's not that basically. And so for blurring, if you want to blur your image, what you do is you could also use OpenCV to do that. There are other packages. You could use Scikit image, you could use Peel to do this sort of stuff, or you could even like build your own kernel to do this, which in other videos I'll be explaining when I advance to the level of coding this stuff from first principle. That's giving you the two key that you need to be able to develop libraries such as OpenCV. So I'll show you how these functions are actually coded. Someone coded them and graciously made it available for everyone to use, but you could also code it and make it available for people, or code it in a different way, basically, if you want to test the knowledge. So to blur, there is something called Gaussian blur. Gaussian, if you're already familiar, I'm assuming at this point that people are familiar with some of these terms. Gaussian, it's like a bell shape, and so basically your image, think of it like within a window size, there's a distribution that looks like a bell. And so it's like lower values by the side. In the center of your image, or of the window that you're moving across the image, you have sort of like a high value. So it's like a weight. Think of weighting of a window that moves across your image, and this weighting is such that you have maximum value in the middle, and that kind of like gives it like a bell shape. And so if you do that, it's like you are like averaging values within your window, but it's maxing at the center, and because of that, you effectively smooth your image. And so let's run this on our image and see how it looks like when we smooth the image. So this is the blurred Again, I'm using a very tiny window size at this point, but I could like bump it up. Like now you could hardly see the difference, even though this is blurred. This is not blurred, this is the original. I'm going to close it and change the kernel size. So this is what is called kernel size. Here I'm using 9. Let me just create a variable here for kernel size, or let's just call it a kernel, and let's call it a 9. You could just define this entire stuff outside here so that we don't get to change it there. So let's just put that there and move this into here. Let's change this to 50, for example. 50 by 50. As the window, that's basically that window that is sliding upon our image is of this size big. When it was small, it was as good as not doing very much. So it's basically averaging within a 9 by 9, and the information wasn't too obvious. But now I'm running it. Sorry, I ran into some issues. Let me see why. A kernel 0 50 by 50 looks like it's too big. Let's just I don't want to, I'm already running out of time, so I don't want to start making more changes. Let's run this and see if we get that error. It's because of the size. If we change this to 15, and if we run this on our gray image, we'll run it, it doesn't matter actually. So that size was just too big, so I changed it to 15 and it ran now. It's blurred, but it's not very obvious actually. Let's see how max we could go. If we go to 25, and if we run this, yeah, definitely now we could see stuff being more blurred compared to this other original image. You could bump it up, maybe go to 35. I know that 50 didn't work, or maybe I was not supposed to use an even number. There's also a chance that that's what's happening. It's more blurred, but the size of an image is really big. It's 6,000 by 4,000, so we're just like not doing very much. If we increase it to a very obvious number, say 535 by 535, let's see what happens. It goes through. So basically it was because I was using an even number. It was a 50, that was why it was like. So now we have obvious blurring. So we have this stuff to be totally blurred. You could reduce it if you want to show more features, but that's how you do it. I don't have to do it on the grayscale image. You could do it on your color image too, and that will work too. So you just basically change that to image, and if you run it, that should do it successfully. So that's how you get to do blurring of your image. I will now show you how to do edge detection. Again, this is just an intro. I'm just giving you a kind of like glimpse into the possibility of what you could do with computer vision. I'm not necessarily at this point explaining in detail what each of those, how to do it, basically just an idea. So here we want to do edge detection. Hopefully I typed this correct. Yeah. And so for the edge detection, let's pick out blurred image, which is that image. Since we want to use it for the next step, I will try to reduce the blurriness of the image. Let's just use, say, 35 by 35. Could comment this out and just run this line. And now we have our blurred image. Let's try to detect image and the edges in those images. So it basically has like, again, it has like a kernel that is designed, or a filter. Think of it as it's like a filter that moves across your image, and as it's moving, it's sort of like summing up the intensities within that window size at each position, and then getting a new value and then placing it in this new image. So it effectively sort of like gives you like a sum value of the filter. So basically that's what the filter does. So we're just filtering our image. I don't want to go into details. I'll do dedicated videos for each of this one to explain everything in details with graphics, so it's more obvious to catch. But this one, just think of it as you're filtering the image, and by filtering it, the filters are organized so that if you slide through your image, you could catch vertical or horizontal edges, or a combination of both. I will explain this more in other videos, in future videos. So please subscribe so you don't miss up on other stuff. Let me just define our figure. Again, I have to do PLT before the figure, so I'll do PLT the figure, and then let's run this on our blood image. And then if you run this now, it should, oh, you couldn't find anything that's interesting. I think it has to do with the CMAP. It's going to the value. We have this as once. So this is the thresholding value. For you to threshold your image, you have to know the value they want to use. So 50 was obviously too big, couldn't find anything. Let's change it to 5. Probably if I go higher, it should be better, but it's just an idea at this point. Okay, so we begin to see, so there are those edges here. It was because of the smoothness. We had like stuff being too smooth, so it was hard to see the edges. But now, like if you zoom in here, you could see my edge, my head here, my hair, yeah. So those are the edges, obviously. I don't want to waste much time, but that's how you just run it. So it's based on you set this value, this stretching value, and within which range you want to consider. So that's the ear, that's the hair. I'm going to take that back home, and then that zooms it out, and that is the drawing. So if you want to do a pencil drawing, that's some hack, and then even some math on the board that's showing up. Cool. So that's for edge detection. So we've successfully just detected edges around this. These are the obvious one based on this value, which is black. That's what it's catching. If I go way wide, it should be able to catch this one too, but that's not important at this point. Now, after we have sort of like detected this, there's also what is called feature detection. So instead of focusing on just the edge, we'll also focus on the entire feature. So let's try to do that. Let's try to do, well, I think I'm going too long into this video at this point. Let's just add it there.